Yes, Assalamualaikum and good morning. And can everyone hear me, please? Respond.
Can sir.
Yes, sir. Okay, sir. Good morning,
Okay,
sir.
all right then. Um, I have uploaded the two new things, right? Two new materials. Because last time I think I did not upload the scheme of work. So let's take a look at what you have seen there. Right, what I want to describe a bit is on the scheme of work. Right, we have four chapters, right? Series solution, Legendre polynomial, Fourier series, and classical equation. And right, so the evaluation which you should be um, taking note is actually the assessment one. It will be 13%. It will include section A and section B. Assessment two again is 13%, and assessment three 14%. So altogether, what you have there is 40% for the continuous assessment, and then the final examination is 60%. So altogether, that makes up the for your grades. All right. So I hope there is no questions. It's fairly straightforward, isn't it? So each assessment will contain two questions, right? Section A and section B. So concentrate more on section B because it will be it will contribute 10%. Okay, so kalau tak ada soalan, we will proceed to the. You can refer to this later. And now we can proceed to the what I want to do now, right? The because this for these sessions, uh, I will go through the review of PowerPoint, right? For these sessions, right? I will go through the two notes. First, on the review of chapter one, review of power series. Semua orang boleh nampak apa yang saya tuliskan?
Boleh sir.
Boleh sir.
Okay. And then number two, we will look into the classification of points. So, so next week we can start with series solutions at ordinary point. Okay. So let's take a look at the first part, right, on the review of power series solutions. Right. In this particular chapter, what we want to do is um, to learn how to solve second order ordinary differential equation, right? How to solve yang ni tertinggal dia punya how to solve second order ODE with variable coefficients, right? It will be in this form. Is P of x times the second derivative, Q of x times the first derivative, and then R of x times y, and then this will be that one there should be 0 or g of x, something like this. Right? And p, q, and r are polynomial is x, g of x could be constants or algebraic expressions, trigonometric functions, log function, or exponential functions. And the only way to solve the above equation is to use the series solutions. Right? This is the only way to solve this using series solutions. Right? Please note that if you have the p, q, and r are all constant, so it will be we will be using uh, the method of finding the characteristic equation as you learn in M80 435 or M80 235. Right, so this knowledge will be used again in chapter 4 on classical PDE. All right, so for now we need to review the definitions of power series. All right, the power series in terms of x is defined by this. All right, so it will be the summation from n equals to 0 to infinity a n x minus x naught raised to power of n. So if you expand this one by one, you will have this. So the terms in the series is infinite, and it can go on forever. A n represent the coefficients of the nth term. X naught is the constant, and x varies around x naught. Right? For this reason, we call the series, right? The power series is expanded about x equals to 0. Right? This series usually arise as the Taylor series of some functions. So what you have for you when the Taylor series, right, if x equals to 0, right, the function, the power series will be in the simplified version, right? That should be n anyway, not x, right? It should be the summation of a n x to the n, not x to the x. So if you expand it one by one, right, it will take this form, okay? And the series associated will be associated as Maclaurin series of a non-functions. I am sorry. Oh, where is the rest? Hmm. I am sorry. I think I just made the wrong one. I am sorry. But the one that you have, sorry about that. The one that you have, I hope this one, yeah. Right. This is what you have in the. Okay. So what we have. This is actually the Maclaurin series, right? For the first function, if you these are examples. The one in green, these are examples of Maclaurin series of 1 over 1 minus x. Right? This can be put in series form, right? And if you expand this, right, 1 over 1 minus x can be represented as series, right? 1 plus x squared plus x cubed and so on. Right? Secondly, when you have e to the x, it will be it can be represented by the summation of x to the n over n factorial. So this one here is the expanded form. And then the third example is when you have sign there, this is the series there. And the right hand side here is actually the expanded form. Please note it that note that the power series, the negative powers are not permitted. All the powers of x there in the power series is positive. It cannot be negative. The coefficient of the power series must not depend. And me again, there's a mistake there. Must not depend on x. Right? Must not depend. Right? It shouldn't be dependent on x. If you have a series that looks like this, right? This is not a power series because what happens there, the coefficient depends on x. Okay, and on the operations of the power series, you have addition and subtractions. Right, so all you need to do there is to add the like term. So that means you only add the corresponding term if the power of n. All you need to do is to add the like term. That means if you have coefficients of x cubed, you must add the coefficients of x cubed alone, and so on. So that is addition and subtraction. As far as multiplication is concerned, this will be, even though it is very short, but this will be tedious because you're going to multiply every term in the first series to every term in the second series. So that is on multiplication. What is more important there is actually the differentiations. Right? Given um, domain of convergence, a given power series can be differentiated or integrated term by term. So what you have in this particular case, if you differentiate term by term, right? Let's say we take this. Now we want to differentiate this. Let's say we want to differentiate this particular function. This is for this f of x is the summations from n equals to 0 to infinity of a n x minus x naught raised to the n. So this is a power series expanded at x equals to x naught. Please remember that when we expand this, it will be the first term there is will be a naught, and then x minus x naught raised to the power of 0, so that will be 1. Second term is a1 x minus x naught raised to the power of 1, and then the third term will be a2 x minus x naught squared. Third term will be a3 x minus x naught cubed, and so on. It goes on forever. Please do not forget to indicate the triple dot at least. You can use 4 dots, but the three dots there indicate the term continues forever. So if you want to differentiate this, you can either differentiate this using the short form. So if you the first alternatively, the first way to do this is to use the short form there with the summation, the closed form, right? This is called the closed form, right? The closed form, this is the expanded form. So if you differentiate the closed form, it's just like the differentiations of the normal function, the n there, you bring this, it will be n a n x to the minus x naught raised to the power of n minus 1. But then again, what is important is that n start from 1 to infinity, right? Because you have a constant term there. If you differentiate, and this is if you differentiate the closed form. If you differentiate the uh, expanded form, it will be, because if you differentiate a naught, it's just a constant, so it will be 0, isn't it? So that means what you have is just the next one is just a1, right? A1 and then times x, a1 there alone, right? And then you have the next thing is 2a2 x minus x naught, and then 3a3 x minus x naught squared, and so on. So it will be, if you put it in a closed form, it will be similar to the one that you have in the closed form. Ada soalan tak?
Tak ada sir. Okay.
Boleh faham ya? Because yang ni penting ya. Kefahaman yang ni adalah penting bila kita differentiate ni kita akan pakai. Jangan silap especially on this on changing the index ni please notice So bermakna when we are doing the second derivative, right? If we are doing the second derivative, right? We take the derivative of this. Paling mudah in this case, right? So it's the same thing, right? So it's just like differentiating normally, right? So it's n times n minus 1 a n x minus x naught raised to power of n minus 2. Tapi you kena ingat, for this there, n start from 2 to infinity. Right? Nah, ini kena ingat. Right? Because when you have this, when you have n there, you will have a constant. This one is just a constant. So that's why when you differentiate for the second time, the index start from 2. Then kalau you ambil f, the third derivative, ini tak ada dalam soalan, because dalam soalan dia suruh cari the first and the second derivative only kan. So what you have there, the third derivative in this particular case will be the summation from n starting from 3 to infinity, and then you have n times n minus 1, n minus 2, a and x minus x naught raised to the power of n minus 3. Alright, so I hope that is fairly straightforward. Okay, let's proceed to, kalau tak ada soalan, let's proceed to the next one. Okay, so what we have is this one. This is slightly different. The next examples here. This is slightly different. This one here. Now, the only difference in this particular case, you have yang tadi kita ada the index is n only. Here we have additional index n plus r. So you want to find the first and the second derivative. So in this particular case, y is the summations from n equals to 0 to infinity a n x minus x naught raised to the power of n plus r. Now please remember that r is just any number in real numbers. So faham kan apa maksudnya r is in real numbers? Faham tak maksud real number tu? Bagi example dia number kalau you faham. Yang ni kalau you tak faham apa yang dimaksudkan dengan real number, then you will mix every number is real number. Not all the time. It's not true all the time. Hello, boleh faham tak apa maksud real number?
Tak tahu sir.
Okay. So basically, when you have real number, is any number when squared. Any number when squared gives positive number. Itu definition of real number. Sebab ada tak number yang you square jadi negatif? Pastinya ada kan? Boleh bagi contoh tak? Kalau you square akan jadi negatif. Ada tak?
Rasanya tak ada sir.
Rest tu tak ada. Okay. Kalau kita ambil yang the simplest one, the square root of minus 1, ni nombor ke bukan? This is a number,
Nombor.
otherwise
Ya.
it's a number. But if you square this, right, it will be equal to minus 1 because this is imaginary number ataupun complex number. Right? So sebab so basically when you have kalau you have this because dia kita tengok tadi any real number is actually a number when squared gives you positive. So bila imaginary basically real number ni termasuklah any number you can think of except yang imaginary. Right? That's a bigger set. Some under you have rational ke, right? Kalau you have real number, you can any number you can think of yang fit the criteria. Any number when you squared gives you positive number. That is a real number. So at the same time, there are another classification as rational number. Rational number is any number which can be expressed into A and B, where A and B are integers, right? So examples of rational number is any number which can be expressed in ratio form, 5 over 2, 3, which is can be expressed as 3 over 1 or 6 over 3, 6 over 2. Dan seterusnya, number which can be expressed in ratio form. So that is also a real number. And then the other one is irrational number. Irrational number which is denoted by any number examples is square root 2 is irrational number. And then you have integer. The set of integer there, which is a whole number minus 3 minus anything from a negative integer, minus 1, 0, 1, 2, 3, and so on. So these are integers. All of this, and all of these are real numbers. Can. So when you have r as a real number, so if you expand this back to this, if you expand this, this will be a naught, and then you have x minus x naught raised to power of r. Second term, a1, x minus x naught, 1 plus r. Third term, a2, x minus x naught, 2 plus r. Dan seterusnya, isn't it? So when you do this, dia tak ada constant term. Right? This series does not have constant term. Kena ingat ni. Dia lain daripada previous example. Right? Previous example yang atas ni ada constant term, which is this kan, A1 kan. Yang ni tak ada constant term. So please keep in mind. So before we, so when we integrating, differentiating this, so if we differentiate y equals to this, n equals to 0 to infinity, a n x minus x naught raised to power of n plus r, if we take the derivative dy by dx, right, dy by dx there, it will be the summations. Right, sama macam the idea is n plus r and then a n x minus x naught raised to power of n plus r minus 1. But then again, n still start from 0. Right, dia tak tukar dia punya index. Please keep that in mind. So sama juga kalau you ambil the first derivative, the second derivative d2y by dx squared. The second derivative sama saja except that the index doesn't change. Right, so you still have n plus r minus 1 an x minus x naught raised to power of n plus r minus 2. Right, so third derivative sama Boleh faham kan? Kalau you nak ambil the third derivative. Boleh?
Boleh sir.
Sir,
Boleh
saya tak
sir.
faham. Kenapa indeks tak tukar?
Kenapa indeks tak tukar? Tak ada constant. Yang tadi ada constant.
Oh,
Kan? Faham tak?
okay.
Yang tadi tak ada yang ni mana ada constant? Kalau you tengok ni, you expand this, mana ada constant? Because the first term tu is this. This is the first term. Dia bukan constant. So itu perbezaan je bila ada R. So perbezaan ni ketara, and this is kita akan guna ni, the difference is that yang ni bila kita ada regular singular point. Ceritanya yang atas ni, yang example yang atas ni kita akan guna bila kita ada ordinary point. So bermakna kalau you tak careful, you confuse, ambillah cerita. Because solution at ordinary point dengan solution at regular singular point akan berlainan. Itu yang kadang-kadang ramai bila lepas exam kan ataupun lepas final assessment dia rasa dia boleh buat tapi fail. Sebab itulah dia jadikan solution at ordinary point jadi solution at regular singular point. Jadi dah lain, orang suruh pergi utara, dia pergi selatan. Orang suruh cari ayam, dia cari itik. Jadi mana dapat? Lain kan? Faham tak? Jadi first of all, bila ni yang penting, the basic. The basic thing is differentiation ni, you kena bila the basic thing, bila you differentiate ni, you cerita pasal regular singular point ataupun ordinary point, because you kena treat these 2 point differently. They are not the same thing. Okay. Kalau tak ada question, we can proceed. This is right. So we have done up to this. Yang ni you ada dalam tu. Now the next part is index shifting. Right. Yang ni penting juga bila kita shift the index ni. Right. Ini satu perkara yang penting juga yang you kena tahu. Index shifting. So when we shift the index, if we want to shift the index, right, in this case, the index start from n equals to 4. So if we want to start shift the index from 0, right, notice that here you have the index is at 4. So here what we want is to shift the index at 0. So the only thing that you want to do is to let n minus 4 equals to m. Right, so you will have 0. So kena tukar kan, n jadi m plus 4. Right, so when you do this, yang ni you kena perhatikan elok-elok. So that means we can still use the index n, tapi the index start from 0. So, but then again, the expression will be slightly different. But when you expand this, you will still get the same expanded series. Itu pun penting juga. So please be careful with this, right? Yang index shifting ni pun very important. Next one, yang ni this is an example. Change the start of the summation index to 2. Right? Change the start of the summation index to 2 for f of x equals to the summation from n equals to 4 an x minus x naught n plus r. So what you want to do there, yang ni, this one n equals to 4, you want to make it 2. So what you want to do is to change, right? Is to shift n becomes n plus 2. Right? So bila n becomes n plus 2, so you just shift everything to n plus 2 there. Right? So n jadi n plus 2. So you have n there kat sini n plus 2. So this is how you shift the index. Ada soalan tak?
Tak ada soalan.
Okay, so the next part yang penting sekali adalah formulations of the Taylor series expansion. Right? Taylor series expansion. Why it is the Taylor series definitions that we define this as the Taylor series. Right? Any function f of x which is infinitely differentiable at x equals to x naught. The Taylor series expansions is given by this expression. Ni you kena tahu dia punya formula. Is the summation from n equals to 0, the nth derivative of f evaluated at x naught divided by n factorial x minus x naught raised to the n. So kalau you expand term by term, right, this is the first term, right, this is the first term there. Then you have the second term, the third term there. If you substitute n equals to 2, then the fourth term, if you substitute n equals to 3. Okay. The fn, f power raised to power of n, x naught there means the nth derivative of f of x. Okay, so the next part there, ini dia punya formula for Taylor series expansion. So examples in this particular case, right, yang ni, find the Taylor series expansions of e to the x. Yang ni, the Taylor series expansions of e to the power of 2x ni. What you want to do is to find, tak boleh tulis ni, so I am sorry, dia punya tu sudah hang. I am sorry, saya kena close balik. Kalau tidak, saya tak boleh tulis apa-apa. Sekejap, saya kena okay. Kita sampai okay, this one. Kita nak cari the Taylor series or expansions of f of x equals to e to the x. So you have this as f of x. So apa yang up to the fourth term, so bermakna kalau ikut formula tadi, Kalau ikut formula, the Taylor series expansion tu, right? The Taylor series expansion is the summations from n equals to 0 to infinity, the nth derivative at x0 divided by n factorial x minus x naught raised to power of n. Nah, itu ceritanya. So, bermakna kita kena cari, right? Kalau you nak up to the fourth derivative, so you bermakna you kena start from n equals to 1, right? You kena expand this. You kena cari n equals to 0 plus n equals to 1 when n equals to 2, then the last bit is when you have n equals to 3, isn't it? So that's why daripada sini you kena cari the third derivative. So here, what you have is cari the first derivative of f, second derivative here of f, the third derivative of f ni, do it carefully. Then you kena cari the expansion at x equals to 2 kan. So makna you kena evaluate the function at x equals to 2. So f2 there is e to the power 4. First derivative is at 2 there is 2e to the power 4. And then the second derivative at x equals 2 is 4e to the power 4. And then the third derivative is 8e to the power 4. This one is fairly straightforward, isn't it? So what you want to do there, you just substitute, right? Just substitute one by one. Okay, and then simplify. Right, so that means you have this. Okay, just substitute one by one, then simplify. So that's it. So itu cara untuk cari the Taylor series expansion. It's fairly straightforward. You kena tahu formula ni je, this particular formula. Kalau you tak ingat formula ni, habislah cerita. Just replace x naught by 2. Ada soalan tak? Hello? Ada ke tidak? Tak ada kan?
Tak ada sir.
Orang
Ada sir.
dia bila senyap takut orang tak ada, line terputus kan, kita short sendiri je. Okay. This is the last bit, right? The principle of superposition. Ni ceritanya apa yang dimaksudkan principle of superposition which we will apply dalam chapter ni dan juga chapter 4 nanti. So if y1, y2, y3 up to yn are solutions to a differential equation, then the linear combinations of the y1, y2 ni bermakna macam ni right? Kita tambah c1y1 plus c2y2 plus c3y3 up to cnyn. These are the solutions of the differential equation. So dalam chapter ni, for example, what we have there, we have first solutions y1 of x. Second solutions is y2 of x. So that means the general solution, right? The general solutions of the series is y equals to c1y1 plus c2y2. Dia ada dua general solutions. Tapi in chapter 4 dia ada banyak solutions. So itu sahaja. And for this, saya nak you cuba buat untuk homework questions number 1 and question number 2. Itu sahaja untuk this part. And then find the Taylor series expansion about the specified point. Dalam buku teks, kalau you tak faham ni, boleh cari soalan dalam buku teks. So, ada dua buku teks, satu Boyd, satu lagi is Zil. Alright, dia lebih kurang sama je. So, kalau tak ada soalan, we can proceed to the next part. Right, so yang ni, tak ada soalan
Tak ada sir.
Okay, kalau tak ada soalan, we can proceed to the next part. Kita cari classification of points. Now, on classification of point, ini penting ya. Classification of point is the most important part ya. Sebab of the chapter, kalau you want to solve this, because we have to. Kalau you tengok dalam ni pun, dalam dia punya scheme of work, I am sorry, I just need to refer back to the scheme of work, schema ni. Dalam ni, please keep in mind, dia ada review of the power series solution, and then series solution near ordinary point, and then series solution near regular singular point. Ini yang penting. Kalau you tak boleh bezakan antara dua ni, ambillah cerita. Sebab that's the main thing. So kita kena classify the points at whether the point is ordinary point or regular singular point. So failing to classify ni tak boleh nak cerita apa dah. Right, so the next part in trying to solve a series solution is for you to identify the nature of the point, right? The nature of the point in question. Sama ada kita ada ordinary point ataupun regular singular point. If you miss this part, ambillah. Ada apa? So kalau yang orang Islam je, kalau solat tu, bab suci, mensucikan hadas, you dah out dah kan? You tak basuh. You buang air, you tak basuh. Habislah cerita. Apa lagi nak ambil wuduk kan? Betul tak? Faham tak apa yang saya cakap ni?
Faham saya.
Faham kan? So kalau you katakan you nak solat, bab apa ni, bab bersihkan diri selepas buang air pun you tak kisah, habislah cerita. Wuduk pun tak sah, apatah lagi sembahyang. Tak ada apa-apa lah. Biasa je. So untuk ni, perhatikan ya, please keep in mind, right? Before you start solving for the solution, you must identify the nature of the point. Kadang-kadang dia akan bagi dalam question, dia akan bagi find the series solution at a regular singular point at x equals to 1. So bermakna dia dah beritahu dah x equals to 1 is a regular singular point. Ataupun dia akan tanya find the solution at an ordinary point x equals to 0. Dia dah beritahu kan, ordinary point. Maknanya you boleh terus, because you have been identified, you have been told it's an ordinary point. Most of the time, dia tak akan beritahu. Dia cuma beritahu find the series solution at x equals to 2. Jadi, you kena identify whether x equals to 2 is ordinary point ataupun regular singular point. Failing to do so, you terus jump to a conclusion it is an ordinary point is a big mistake. Habis cerita lah. Tengok nasib lah. Sama ada x equals to is ordinary point ataupun kalau kebetulan ordinary point, dia cari ordinary point adalah markah. Tapi tak boleh markah penuh. Kalau x equals to 2 happens to be regular singular point tapi you assume ordinary point, habislah cerita. Because you dah buat kerja for 3 pages, 4 pages. Habis cerita. Tak ada apa-apa nak dibagi. So itulah yang biasanya terjadi apabila pelajar, because the first thing that you need to do dah habis lah. You are missing the whole thing. Macam nak buat rumah, you nak buat jalan ke, you nak buat jambatan ke, you don't check the foundation. Apa jadi? Apa jadi?
Roboh.
Fail.
Most likely apa jadi? Roboh lah. Kalau kebetulan dia punya foundation tu bagus, okey lah kan. Tapi most likely foundation tu tak tahu lagi. So you cannot assume. You cannot cut corners. So please remember, memanglah you takkan guna matematik ni dalam nak buat bangunan. You nak buat bangunan pun kira campur tolak je. Kira kos kan, itu je. Tapi yang lain sebagai kajian sahaja. Tapi pentinglah, all the steps there is important. Okay, so the definition to identify the nature, this is the definition. Yeah? Given a second order ODE with variable coefficients, right? This is the same ODE that I discussed earlier. If P of x naught is non-zero, then x naught is called an ordinary point. Senang saja. Ordinary point kalau P of x naught is non-zero. And then kalau P of x naught is zero, then x naught is called a singular point. Tapi a singular point ni, ni simple. Dia ada regular dengan irregular. If both the limits, ni limit yang pertama, equals to B, limit yang kedua, equals to C, and they exist, then we call this as a regular singular point. If either one of both limit does not exist, saya tertinggal ni kat sini. If either one of the limit does not exist, makna tak wujud, then the point is an irregular singular point. Saya tertinggal does not exist. So, ceritanya senang je. Dia ada dua point, satu ordinary point. What is the criteria? P of x naught is not zero, kalau ordinary point. Then the next one, P of x naught is equals to zero, then you have singular point. But singular point, it can be classified into two. It could be regular ataupun irregular. Regular singular point, both limit must exist. Okay? So ada soalan tak?
Tak ada, sir.
Okay, kalau tak ada soalan, we proceed to this. Okay? Find all the ordinary point and the regular singular point of the ODE. So this is the given ODE. Alright, so what you want to do there, you have to identify this is your P of x, this is your Q of x, this is your R of x, as I identified here. So yang ni carefully written. So untuk cari ordinary point, you want to know, you want to solve P of x not equals to a zero. So makna ni you kena solve this inequation ni. Right? So what you have there, x cubed is non-zero and x minus 2 is non-zero. So you have, as long as x not equals to a 0 and not equals to a 0, you have the ordinary point. So therefore, you can say that hence the ordinary points of the ODE are all the points in the real number except x equals to a 0 or x equals to 2. So daripada sini, you can conclude x equals to 0 or x equals to 2 as singular point. Tapi singular point, you know that it will be two types. Regular singular point ataupun irregular. So, kita dah cari ordinary point. So now, to check for singular, tak payah cari because we know it already. Right? So we want to know at x equals to 0 is a singular point. So now, kita kena check if both limit exist. So kalau both limit exist, okay lah. So in this case, this is the first limit. This is the first limit daripada formula dia. This is the limit. The first formula is x approaching to x naught, x minus x naught times q of x over p of x. Kita dah cari kan p of x dengan q of x tadi. So you just have to just substitute x naught by 0. So you have the first term there is x. This is your q of x. This is your p of x. So therefore, in this case, you cari ini. Then bila you substitute, it will be infinity. So bermakna the limit does not exist. And bila limit does not exist, the point x equals to 0 is an irregular singular point. Okay, so untuk irregular singular point, either one of the limit does not exist. So tak perlu check for the other point. It's fairly straightforward kan? Okay, kalau tak ada questions, we can now check for the point at x equals to 2. So at x equals to 2, right? So you have p of 2 is 0, so therefore you can conclude it is a singular point. So now you check the first limit. The first limit. Right? This is the first limit. Right? And you will just substitute everything there, find the limit it is equals to 0, so the limit exists. And then the second limit, right? Yang ni. Right? So that's the second limit there. Right? It's just a matter of, because you can guna formula limit as x approaching to x naught, you just substitute x naught equals to 2, x minus x naught squared, and then r of x over q of x. That's the difference. So therefore here is 0. So therefore both limit exist, and you can conclude that x equals to 2 is a regular singular point. So itulah selesai ya. And then in the second example, ini lebih kurang, cuma dia ada sin and cos. Sama, lebih kurang sama. Find all ordinary point, ordinary, regular and irregular singular point for the differential equation. So sama sahaja ceritanya. In this case, you have p of x as x sin x, q of x is cos x, r of x is e to the x. And then for ordinary point, you don't want p of x to be 0. So therefore, dia ada dua. 2x equals to 0, and then sin x equals to 0. So therefore, x equals to k pi. Boleh faham tak ni? Sin x not equals to 0 means x is not equals to k pi. Boleh faham tak?
Tak faham.
Tak faham. Okay. Bila you have sin x, let's take a look. Kalau sin x equals to 0, yang tadi tak equal kan? With the sin x not equals to 0, you faham kan dia punya graph of sin x ni is up and down macam ni, betul tak? Okay. Yang ni, the peak position is 1 and then it's minus 1. So it will be 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, dan seterusnya kan. So x there is 0, pi, 2 pi, 3 pi, 4 pi, dan seterusnya. So therefore this is equals to k pi, isn't it? Where k is an integer. Faham? Because dia yang ni saya tunjuk positive, dia can go on to the left hand side also. So even if k negative, you still have the solution. So therefore, for sin x not equals to 0, x is not equals to k pi. K is an integer. Faham kan?
Faham.
Okay. So itulah ceritanya why x is equals to k pi, k is in z. Okay, so what you have in this case, the ordinary points are all the points in the set of real number except x equals to 0 and x equals not equals to k pi, where k is in z. So itu untuk ordinary point. So untuk regular singular point, sebab dia ada dua point kan, x equals to 0 and x equals to k pi. So Kita kena check x equals to 0 are the singular point. So we need to check for regularity. So untuk x equals to 0, ini the first limit. This is the first limit. And you find out kalau you cari ni, the first limit ni, right? So the x cancel is cos x over sin x. So you have to divide it by 0. So that means the limit is infinity. So there is, and the limit does not exist. So therefore x equals to 0 is an irregular singular point. Okay, so for x equals to k pi, right? K is non-zero integer. So first limit is this. So untuk first limit ni, what you want to do is to use L'Hopital's rule, right? Because it's in the form of 0 over 0. So now, for the first limit, kalau you guna L'Hopital's rule, you have this. So yang ni you check it out. Okay. From the second limit, for the second limit, what we have there, this is the second limit. Sama sahaja is in the form of 0 over 0. So you guna L'Hopital's rule and you check the working there. So it will be 0. So therefore, both limit exist and hence the point x equals to k pi is a regular singular point. So itu sahaja untuk the nature. So untuk ni you cuba exercise 1.2 ataupun you ambil exercise dalam buku Zil ataupun Boyd. Yes, Boyd. Dalam ni Ada soalan tak?
Tak ada lagi kot, sir.
Okay, so please make sure you copy balik, buat the exercise yang sikit ni pun. Alright, and before you go, I need just because yang ni saya tak print, apa ni, your attendance sheet. So what I can do is just capture this. By Hairul Arina. Then we have this Amelia. Okay, so itu sahaja. Ada apa-apa you boleh tanya saya melalui apa ni WhatsApp ke. Alright, so I'll see you on the punya time should be on berapa Monday
Yes, sir.
Okay, so boleh kot you all kita punya lecture is on Monday 8 to 10, right? Dan satu lagi is hari ni Tuesday. Tak adalah dia rapat-rapat sangat kan. Everyone ada masa terluang kan? Betul tak?
Betul, sir.
Okay, so kalau ada masalah makna saya punya tu sebab saya tak nak dia berturut-turut. So dia punya lecture will be on Monday and on apa ni, and most of the time Saya akan guna masa 1 jam saja untuk bagi lecture. Untuk hari ni pun sepatutnya ni, itu pun tak melebihi 2 jam. Because pada saya lah, kalau lecture 2 jam online tu dah mengarut dah. Dan tak tahulah kalau awak tahan kan. Kalau saya sendiri tak faham, saya tak tahan. Untuk bagi lecture 2 jam non-stop. So itu saja. Ada apa-apa beritahu saya melalui WhatsApp. Okay, thanks very much.
Okay, sir.
I'll see you
Yes,
next
sir.
week.
Thank you,
Baik,
sir.
sir.
Thank you,
Yes,
sir.
sir.
Thank you, 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 sir.